How will you solve this question number 10, right? So here this is based off functional equations. So f of x plus y equals to f of x plus f of y. So for this type of expression only the function is possible k times x. Only we need to find value of k. As you can see here, some values of f of 1 equals to 7. This type of values are given. So here if function is f of x equals to k times x, then what about this f of n? So if we put x equals to 1, we will get k into 1, that is equals to 7. So value of k is equals to 7. So if value of k is 7, that means our function is 7 times x. This is the function. So here question is given, find the value of this expression. Sigma r equals to 1 to n f of r, right? So where r is equals to 1 to n, that means we need to put value of r as 1 to n. So if we put here r is 1, so we will get 7 times 1. If we put r equals to 2, we will get 7 times 2. That means we need to add here. Sigma means we need to add. So like this we need to add all these functions up to n. So we can take 7 common. So this will become 1 plus 2 plus 3 plus 4 up to infinity, up to n times, right? So what is the sum of these numbers? Sum of natural number, that is there is an expression, that is n into n plus 1 by 2. So I think same option is given here, option number D, right? Again, how will you solve this question number 11? So in the question number 11, actually some function is missing here. So in place of this expression, we need to take some value of a, right? Because we need to find the value of a raised to half upon a raised to half plus a raised to half. Yeah, here we can find out. So that is equals to root a plus root a plus root a. So root a upon 2 times root a, right? So no need to give the value of a here. So this will get cancelled, or we are getting half, right? Now let's solve this. Again, if this type of function is given, if the function is given like this, f of x equals to some constant raised to x divided by some constant raised to root of the same number. So then f of x plus f of 1 minus x, this will be equals to 1, right? So here, as you can see in this expression, f of 1997 plus f of, if you see, you can directly just take some value of x, and same function you can write down here just taking 1 minus x, right? So if I take value of x here, and then second one is, it should be 1 minus 1997. If this type of expression you are getting, then value sum of these two functions will be equals to 1. So you can just simplify this number, okay? So 1997 minus 1, that is 1996 divided by 1997, f of this one, plus f of 1 upon 1997. So this will be equals to 1. As you can see, same function is also given here. This is f of 1 upon 1997. This is f of 1996 divided by 1997. So sum of these two functions, this will become 1. So similarly, first and last, sum of first and last function, this will become 1. Similarly, second from first and second from last, sum of these two functions will become 1. So if we add like these terms, so how many total functions are there? 1996 functions are there. So what is the from 1 to 1997? Yes. So here, so if you divide this 1997 by 2, because we are making here pairs from first and last, then second from first and second from last. How many pair will be there? So just this one. So 2 9s are 18, 2 9s are 18, 2 8s are 16. So 998 pairs will be there. These pairs will give 1 plus 1, 1 like this. Each pair will give 1. So we will have 1 into 1998, that is The same is the answer. This is the answer. I think B1 is the correct option. Now question number 12. Here for a real number x to box x is the integral part of x, so we need to find value of this box of half and box of half plus 1 by 100, like this one. Okay, as you can see, this will become 0, this will also become 0, because this number is actually 0.01 and plus 0.05, this is 0.51, right? And box of 0.5, this is equals to 0, right? So up to this is half, so up to half plus half, before these terms all terms will become 0. If you are getting half plus half, so this will become 1, box of 1 is 1, that means this number is changing here. So if you are getting 50 by 100 and half plus 50 by up to this number, before this number each box will become 0 and this will become 1, and after this each box, and what is the total number of boxes? 99. So again see, this is 0.5 last term, this one 0.5 and 0.99. What is the sum of these two numbers? This is 1.49 something, right? So again box of this one will be equals to 1. So from 50 to 99 each term will give 1. So like 1 plus 1 plus 1 up to 50 times. So we'll get answer as 50. So B option is correct. Now next one, question number 13. So in the question number 13, again same type of problem is given, but it is 1999. Okay, so divided by this 2000. So same type of problem is there, just you need to take a look here. This is 1 by 2 plus 19 by 2. So if this number is greater than 2, then its box value will be equals to 2. So this only you need to take care, when it is 2, when it is 1, when it is 0. So add all these terms, you will get answer. Right. Now next one, question number 14. 14 is also easy, just you need to take, here question is f of x is log x and g of x is 1, and f of g of a. So f of x equals to log x and g of x equals to x cube. Then we need to find sum of f of g of a. Okay, we need to find value of this f of g of a plus f of g of b, right? This is equals to, as you can see, f is given log here and we are composing this x cube only here. So that means this function will be log of x cube and this function will be log of, again you can say log of a cube only. Here log of b cube, right? So this you can also write down log of a cube into b cube, that is equals to log of ab whole cube, right? It is some similar, like just we are composing the function here. So that is equals to log of f of g of ab. If you find out f of g of ab, you will get log of ab whole cube. So second option is correct. Now this one, question number 15. So for question number 15, f is defined from R to R, g is defined from R to R, fx is 3x minus 2, that is linear function. Here gx is quadratic function. We need to find out f of g of x square plus 1. So first, from question number 15, first you need to find out f of g. So f of gx, this will be equals to, fx is 3x, so 3 times x square plus 1, that is gx minus 2, right? So then we need to put x square plus 1 in place of x. So this will become f of g x square plus 1 equals to 3 times, in place of x put x square minus 1 plus 1 whole square plus 1 minus 2. So this is the value of x. Previously it was x. Now the value of x is this x square plus 1. Previously it was x only. So in place of x we are putting x square plus 1. X square plus 1 here, right? So now simplify it. So 3 times this you can write down x raised to 4 plus 2x square plus 1 plus 1 minus 2. So this is equals to 3 times x raised to 4 plus 2x power 4 plus 2 minus 2. So 3x square raised to 4 plus 3 2 is 6x square. Here it's square, not x raised to 4 square. This will become plus 6 minus 2, that is equals to, this is 4, right? So in the question it is given this expression is equals to 4. So we are getting this final expression. So the final expression we need to put equals to 4 plus 4 equals to 4. So this 4 will get cancelled out. You can take x square common. So this is 3x square plus 6 equals to 0. So the product of two number is 0. Either first one will be 0 or second one will be 0. So second cannot be 0, right? If you find out here x square, so you will get minus 6 upon 3. So x square cannot be negative. So second one is always positive. From first one we are getting one solution. So the number of solution is 1 here, right? Now question number 16. So here g of x equals to 1 plus x minus this one. So this you can write down 1 plus. Actually this expression is also can be written as g of x. So this you can write down 1 plus fractional part of x. So here we need to find g of 2000, g of 2009. Then value of g of 2009 you need to put in f of x. So here f of x is equals to this one. It is equals to minus 1 for negative value. For positive value it is 1. For 0 it is 0. So only we need to find g of 2009. So for f of g of 2009, so we need to just find out value of 2009. So put value of 2009 here. So g of 2009 equals to 1 plus fractional part of 2009. Fractional part of 2009 is 0. So 1 plus 0 is equals to 1. So this is equals to 1. So here you can write down this f, and g of 2009 is 1. So write down f of 1. Now for f of 1, here x is positive. So the value of the function is plus 1. Because x is positive, this 1 is positive. So value of f of 1 will be equals to 1. Right? Now put second, it is g of f of 9. F of x. 2009, right? 2009. So just put in the function f of x 2009. If you put here 2009 in this function, because 2009 is a positive number, so it will give a value 1. So this is g of 1, and g of 1 put 1 here. So for integer fractional part of x is 0. So this is 1 plus 0. This is also equals to 1. So we need to find g of this function divided by this function. So we are getting value of this function is 1. So 1 by 1, that is equals to 1. So B is the correct answer. Right? Okay. So question number 17.